Hello, Professor. Today we are going to explain about our project called a three-layer privacy-preserving cloud storage schema based on computational intelligence in fog computing. Our group number is 15. We consist of five people: Hemantaki, Shivadatta Gajjala, that is me, Priyanka Ainala, Pranay Siddhartha Kaja, and Pradeep Kumar Chidala. So before starting the about our project, our main concern is about security in the cloud storage, and data privacy. So we thought of sorting this problem using our concepts, uh, the notorious concepts like fog computation. So first we have to know about what is called fog computation or fog networking. It is also known as fogging. It is an architecture that uses edge devices to carry out substantial amount of computation, storage, and communication locally and routed over the internet backbone. Like the main thought of this project is to solve the data privacy issues and to avoid hacking and leakage of our data from the internet or the cloud storage. Recent years, we witnessed the development of cloud computing technology with explosive growth of unstructured data. Cloud storage technology gets more attention and better development. However, in current storage schema, user data is totally stored in cloud servers. In other words, user loses their right of control on data and face privacy leakage issues. The some of the famous data leakage issues are from Apple and Google in the year 2014, where they released numerous Hollywood actors' private photos stored in their iCloud storage. So in this project, our basic system requirements is as follows. The processor should be at least Intel i7 Gen 7, and operating system could be like Windows 7, 10, and 11. The RAM should be at least 4 GB, and the system requirements continues as like this. The tools that we have used are the programming IDE is NetBeans, and database is MySQL, and the programming language that we have used is Java. So these are the few screenshots, the installation for the our tools that we have used. This is for the Java, and this screenshot is for the MySQL, for followed by the MySQL log and NetBeans too. So the data flow graph describes about how the data is flows from one unit to another. This slide explains all about the data. Here the user enters the data by user register himself by entering the data so that he can log in future. And the fog computing, the fog computing shows the data fog and logins, and he continues with the login, and he is further and uploads his private data or any other data which can be even unstructured data or any format of data. And the main code slides comes now. So this line of code explains how we connected to the database, uh, that is MySQL, and these are the few lines of this code. And we have used encryption algorithm standards, that is advanced encryption standard. The advanced encryption standard, we have already have a future scope about implementing the 256-bit encryption algorithms and bitrate of 256 encryptions in future upgrades. This all explains about the source code and how the our encryption algorithms is used to encrypt the data which is unstructured, like any other format of photos, music, video, songs, anything, etc., that user wants to upload. And we also like implemented the we obviously implemented the decryption algorithms. These are the screenshots for the decryption algorithms. Here we can see like the cipher text that we have changed, that is transformed from the regular text to the cipher text using the encryption. Here the main program is about decrypting the ciphertext into the regular text using the keys. Uh, that's it. Thank you, Professor. We are continuing with our friends who are going to explain about integration and testing.
Hi, I'm Praneeth. Today, I want to explain the topic of integration and testing in our project. Integration and testing. First, I'll talk about testing, and then I'll talk about the integration. Testing is a debugging program is one of the most critical aspects of the computer programming because without programming that works, the system would never produce an output of which it was designed. Testing is best performed when user development is asked to assist in identifying all errors and bugs. The sample data are used for testing. It is not quantity but quality of the data used that matters for the testing. Testing is aimed at ensuring that the system was accurately and efficiently before live operation commands. These are the main testing objectives. The main objectives of the testing is to uncover a host of errors systematically and with minimum effort and time. Stating formally, we can say testing is a process of executing a program with intent of finding an error. A successful test is one that uncovers and as it undiscovered error. A good test case is one that has a probability of finding an error if it exists. The test is inadequate to detect possibly present errors. The software more or less conform to the quality and reliable standards. These are the main levels of testing. First, code testing, specification testing, and unit testing. Uh, Code testing the examines the logic of the program. This specification testing executing the specification starting what the program should do and how it should perform under the various conditions. Unit testing. In the unit testing, we test each module individually and integrate with the overall system. And the mainly there are two types of testing on modules. Each module can be testing using the following two stages. We can consider this as a unit testing, like black box testing and white box testing. Black box testing. Uh, Black box testing is a software testing techniques in which functionality of the software under test is tested without looking at the internal code structure, implementation details, and knowledge of the internal parts of the software. This type of testing is based entirely on the software requirements and specifications. In black box testing, we just focus on inputs and outputs of the software system without bothering about internal knowledge of the software program. This is a black box testing. The above figure can be any software system you want to test. For example, an operating system like Windows, a website like Google or Oracle, or even your custom application. Under black box testing, you can test these applications by just focusing on the inputs and outputs without knowing their internal code implementations. Uh, Black box testing steps. These are the generic steps. Initially, requirements and specifications of the system are examined. Test chooses valid inputs to check whether this test process them correctly. Also, some invalid inputs are chosen to verify that the SUT is able to detect them. Tester determines expected outputs for all those inputs. Software tester construct test cases with the selected inputs. As test cases are executed, software tester compares the actual outputs with expected outputs. Defects, if any, are fixed and are retested. This is white box testing. White box testing is the testing of the software solutions, internal coding, and infrastructure. It focuses primarily on strengthening security, the flow of inputs and outputs through the application, and improving design and usability. White box testing is also known as clear, open, structural, and glass box testing. Uh, White box testing involves testing of the software code for the following: internal security holes, broken, poorly structured parts in the coding process, the flow of specific inputs through the code, expected output, the functionality on the conditional loops, testing of each statement, object, function, and individual basis. This is the main theme. Understand the source code and create test cases and execution. Coming to the integration, these are the screenshots of some of my our SQL code. Thank you.
Hi, Professor. This is Aki Hemant from Group 15 and Distributed Cloud Computing. And today I'm going to explain my implementation part of a three-layer privacy preserving cloud storage scheme based on computational intelligence and fog computing. Previously, my friends, my group members explained the design, development, and testing part of the project. Now, my part is implementation part. So I am going to show the uh, user user screen and user windows. So how you can upload your files and everything. So it's the home page. In the home page, you can see home user, fog server, and cloud servers. So first, it's the user registration page. So when you are going to create a Google account, it asks everything like your name, username, passwords, emails, and security codes like that in this cloud storage app. So you should fill the name, password, date of birth, and everything. So after that, you can register into the cloud servers. So after that, after filling these forms, only your account will be created. And this is the user login. By using your email and password, you can log in into the servers. After logging in into this one, so you can see home, upload file, encrypt, view files, view request, download file, log out everything. So these are the main tabs or main files that you are going to see forward. Here you can upload your file by choosing your file, which type of file you can choose. You can choose and upload it to that. And you can also give a name to the file name. After that, encrypt. So you can encrypt. The main basic theme of this protection is encryption. So you can encrypt the text. So after that, you can view the file by requesting it. When you click the request, you can see the files. Before that, it will be in encryption form. After that, view request. So these are the requests in different forms. So send key and everything. This is the actual system behind this one. So you can see local machine, fog server, and cloud server. These are the three main parts. Mhm. In this one, you can store different servers. In the fog server, it's about 4% data. In the cloud server, it's 95. It's in local machine. You can store 1% data stored locally. So combining this one, you can store 100% of the data, and you can restore it. So after that, you can download your files. So by clicking in the download file app or download file tab, you can download it. And this is the download 3 cloud data. You can download every data from here. So this is a frog server. So here you can log in with the same credential which you are used to log in previously. This also same, you can see the view files, view requests and logout. It's a fog server homepage. It's the picture of how the system is working, that's it, but uh, nothing else. So here you can see same, send it to the cloud. From here you can upload, you can see the files and upload it to this cloud server. If not, you can place it in the fog server. So this is the way you uh, can be send the data to the cloud, 95% of it, and view requests and send 4% data from here in the view request tab. And the cloud server, it's a home page. So going back to the home page, you can log in into the cloud servers which you are previously used, logging into the home page of this server. And this is home page of the cloud server, and same as fog server and home page. Here you can see view files, view requests and everything. uh, you can directly upload the files to the cloud by using the upload button as mentioned here. And view request, you can request your data and everything to see that. And that's it. Thank you so much. And my friend Pradeep will continue this presentation and explains you the future scope of this project. Thank you.
Hello, Professor. This is Priyanka Inala. Today I'm going to explain evaluation process of a three-layer privacy-preserving cloud storage scheme based on the computational intelligence in fog computing. In our project, we developed a three-layer framework in order to store the data. As cloud storage is a useful technology which allows the user to increase their storage capacity. And also, in order to manage a vast volume of data, we created a user-friendly interfaces for data entry. And also to address the issue of privacy protection in cloud storage, we suggested a three-layer framework based on the fog computing concept. And also it is very dependable since it allows the users to keep information without any compromising their privacy. And moreover, we used MySQL for storing the data, and Java for coding language in order to write the logic, and CSS is used to do design and develop the web application. Three-layer framework fully utilizes the storage and data processing capabilities of Fog server. And also, the three-layer framework consists of three tiers of architecture like cloud server, Fog server, and a local computer. And each server saves up certain portion of data, and the storage percentage is which is defined with the allocation mechanism used by the users. In implementation, we have three modules. The first one is like data owner. In data owner, the file owner will register with the application and log in with the username and password. If this verification is successful, the client will can upload the files to the cloud server through the Fog server, and which keeps the 1% of encrypted data on the owner's side, and sends the remaining 99% to Fog server for the further processing. During this entire procedure, the data owner will be notified for any action involving in this data, which is kept on a cloud server. In implementation, the second one is the Fog server. In this, the Fog server will function as a tiny storage server, which performs basic functions prior to transferring data to the cloud. After receiving the 99% of data blocks from the user system, these data blocks will be encoded again at the stage. These data blocks is again subdivided into smaller data blocks, which results in the generation of additional encoding information. Here is the bar chart of bar chart which compares the data volume stored in with the users with the number of data blocks. And the final one is the cloud server. In this, cloud storage server provides a storage facilities to register clients for storing outsourced data when they log in with a valid username and password. The storage server can inspect the information of a file uploaded by a user and received from the Fog server. During this procedure, the cloud server will only store 95% of the data. In integration and testing, we have created the web application and integrated to the AWS cloud. And after deployment, an URL is generated which is easily accessible to the users. The users who have an authorization can only access because of its security reasons. Thank you, Professor, for giving us this opportunity.